Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend.
This video is for grade 11 students in Functions and Relations working on the year-end summative. It's question 13.
The current population of Canada is approximately 33 million and of the world is 6.7 billion. Assuming an average 1.4% growth rate, determine when the world's population was the same as Canada's current population. So what we have here is we have an exponential growth rate question. So because it's percentage of growth, we know that that ends up being exponential. So let's set up our equation, and we're going to use P because this is about population. So the population depends on the original population and the growth rate. So our growth rate in this case, and again I'm using 1 plus because it's a growth rate, and the percentage is 1.4, so I need to turn that into a decimal like this. And the growth rate is per year, so that divided by 1 represents that it's a per year growth rate. And I need to say over here that t is in years from now. So we'll say 2015 in case this video exists forever. Forever. Hello, future watchers. So now I'm going to clean this up a little bit. Like I'm going to do the math of 1.4 divided by 100 and add it to 1. And I don't really need to say divide it by 1 because it just sort of makes it look a little less easy to look at. Oops, I said I wasn't going to do that. My bad. So this would be 1.014. And this, I can just put a t over here. So that's the equation that will help me calculate population based on a 1.4% growth rate. So what I'm asked to do in question A is determine when the world's population was the same as Canada's current population. So how long ago were there 33 million people on the planet? So the problem is that because this is a growth rate question, it's going to be tough for me to find ago. So what I'm going to do is I'm going to kind of turn the question around to give me the same answer, which is if Canada now has 33 million people, how long will it take to grow to 6.7 billion? Because it's really the same question, mathematically anyway. So if we start with 33 million people, and I'm just going to say 33. I can't be bothered to write all those millions, so don't forget that 33 million looks like this, and 6.7 billion looks like this. So I'm just going to compare 33 to 6,700 because the math is going to end up being the same. So if we start at 33, how long will it take us, or what exponent will give us 6,700? So the first thing I need to do is I need to get rid of this multiplication by 33. So because the unknown is in the exponent, I'm going to have to solve this using some sort of exponential type math. So what I need to do first of all is isolate the base with the exponent. So this expression in the yellow box needs to be isolated, and that means I need to divide both sides by 33. So 6,700 divided by 33 gives me 203.03. So 203.03 equals 1.014 to the t. So now I need to figure out what exponent makes this base equal to 203.03. And again, if you've seen my other videos on exponential functions, so that would be questions 11, 12, and 13, you'll see that I like to show you two different methods for doing it. One of it is guess and check, because I know that this is what your textbook has you do. So I'm going to guess values for t, see what happens when I put the base 1.014 to that exponent, and then adjust my guess as I need to until I get as close as I'm comfortable getting to this output. And the key to guess and check is to just make sure that you record all of your guesses and checks. So I'm going to start with 50 because it seems like it might take a couple years. Oops. So 1.014 to the exponent 50 gives me 2.004. Yeah, so I'm a long way away. Let's try 200. So 200 years. Is that how long it takes? 200? And that gives me 16.12. So not there yet. Let's try 500. 500 years. A lot can happen in that time. And I get, oh, too many years. 1,044. Too many. Okay, let's try 350. So again, the key to guessing and checking and getting marks for it is that you record your mistakes and your teacher can see the logic of your progression. So now I'm trying exponent 350 and I get 129 point something. So I got to go a little bit more than that. Let's try 420. So 1.014 exponent. I get 343. That's too much. Remember, my goal is 203. So let's try 400 even. I don't know why I didn't try that. 1.014 to the 400. 260. That's too much. Still, let's try 380. 1.014 to the 380. I get 196. We're getting there. A little bit higher. Let's try 385. 1.014 to the 385. 211, a little too much. Let's try 382. And at some point, you just sort of say close enough and move on with your life, right? I mean, I don't know. If I really wanted to know, I'd probably use an Excel spreadsheet. 202.5. 202.5. And what was my goal? Ooh, that's close enough. So 382 years to grow from 33 million to 6.7 billion. So now the question was, so if we started with Canada and we wanted Canada to grow to 6.7 billion, it would take 382 years. So by the same logic, if the Earth currently has this many people on it, then it was 382 years ago that there were 33 million. So let's figure out when that is. It's currently 2015. Again, if you're watching in this future, hello from the past. How are your flying cars? That would be the year 1633. 1633. Queen Elizabeth I had died 32 years earlier. I don't know, is that Shakespeare time? Or is that a little past Shakespeare? I don't know. Anyway, I'm sure you're happy to just sit there and listen to me rattle on about dates I don't know. So anyway, that was the guess and check method, and I do want to remind you that there is another method if your teacher gives you permission. And so we're going to go reset back to this moment in time when we had a simple expression where a variable was in the exponent and we wanted to solve. And the key to solving this is something called the log button on your calculator. Log stands for logarithm, which is a concept you'll learn in grade 12 advanced functions. If you end up taking that course. So here's how we do it. We say that t equals log of what I'm looking for. So log of 203.03 divided by the log of my base. Now, it's easy to kind of get things confused. So the way I remember it is my exponent has the base of here, and the base has to go on the bottom. It just kind of makes sense in my brain, and that way I don't mess up which one goes on top. So in my calculator, I just type log 203.03 divided by log 1.014, and I get 382.17 years. So my guess and check method got me 382, and that log method got me 382. So I'm pretty confident in my answer. Oh, and then the second part of the question says, what will the world's population be in 50 years? So that's a pretty straightforward question. In 50 years, so right now, the world's population is 6.7 billion at a growth rate of 1.4%. And I'm going to put a note here that my answer is in billions. What will it be in 50 years? So I'm going to let t equal 50 and figure this out. Now, again, this is a good moment to remind you that the number is going to be really big and that Earth resources are precious and that we need to be considerate of each other because there's a lot of us on this planet, and we need to be considerate of the planet because for the moment it's the only one we have. And I get 13.4 billion people on this earth in 50 years. So it's going to be tougher to park. All right, I hope that was helpful, and I'll see you in another video. Bye.